Okay, in this video, what I'm going to show you how to do is how to model the empirical rule using the temperature data. I believe we've seen this data in the past in our prior videos. So if this is some temperature values, 31 temperatures during the month of August. This sorted for us, so that'll make life a little easier for us. But let's give a look here. So it says letter A, find the mean and standard deviation to the nearest tenth. All right, so this is something that was covered in in a prior week. I've already put the data in my calculator, I believe in list 2. So if I go stat and choose option 1 for edit, yeah, there's the data in L2. In L1, I have the president data that we've been working with as well. So what I'm going to do right now to work part A is I'm going to crunch the one variable statistics on list number 2. Now this is the newer version of the calculator. And the newer version of the calculator, the menu is a little bit different. If you have an old TI-83, it'll look slightly different. So if I go stat and then move over to calculate, and I'm going to choose option 1 for one of our variable statistics. Notice it says list, and then frequency list, and then of course calculate. So the list that I want to crunch right now is for L2. That's where I have this temperature data. Frequency list, I'm going to leave that blank for now. We're going to use that feature later on when we get to chapter 6, as you'll see. So for now, we're going to leave that blank, and I'm going to go on calculate and let it do its thing here. All right, so as you can see, the mean is about 83.645, and then the sample standard deviation is approximately 4.15. Now, if we follow the directions here, it says find the mean and standard deviation to the nearest tenth. All right, so the mean to the nearest tenth is 83.6, and the standard deviation to the nearest tenth is about 4.2. All right, so for letter A, x bar is about 83.6, and the sample standard deviation, 4.2. Okay. So now what? Well, letter B is the thing that we're really interested in. Using the empirical rule to find the percent of data that lies within 1, 2, and 3 standard deviations from the mean. Now, the empirical rule, if you remember, it's a rule that tells us how, what percentage of the data in a population lies within a certain distance from center. So to set it up, let's go ahead and draw a bell curve. Try to keep this fairly large so we could fit it all, because there's a bunch of info we got to write on it. So we're going to put the mean in the middle. That's 83.6. Standard deviation I'll put up top here, which is about 4.2. And if I stand at the center and walk to the right, a distance of the standard deviation, in other words, x bar plus s, and then back up that same distance, x bar subtract s. Remember, the empirical rule says that we should capture approximately 68% of the population here. All right, so the empirical rule says from here to here, this should be about 68% of the population. So the question really is, when we crunch what these two numbers are, what percent of the data, of this data, of our temperature data, what percent of that data actually falls within these boundaries? Well, in order to answer that, we first need to know what the boundaries are. So let's calculate them. So I'm going to go to my calculator. I'll take my 83.6 and I will subtract 4.2. .6, and I'll also add 4.2. You can see the pen always double clicks. Those values are 79.4 and 87.8. 79.4 and 87.8. All right, well, the empirical rule says we're supposed to catch 68% of the data. All right, so let's see what we actually do catch. Well, if I look at the data, in between 79.4 and 87.8, all right, so 79.4 would start catching here, that 80 would be the first guy, and then 87.8, I would stop counting right here. So if I count all these values, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 of the data values. So remember, there's 31 data values up there. 21 of the 31 data values fall in between those two values. Now, what is that as a decimal and a percentage? If I take 21 and divide that by 31, that is 0.677, and when I move the decimal 2 spots to the right, that's approximately 67.7%. As you can see, this is super close to what the empirical says. Remember, the empirical rule says it's supposed to be about 68%. Oh, so what did I do there? I took the 83.6, the mean, I added and subtracted the standard deviation, got those values. Then I looked at the data and I physically counted how many of those data values fell within those boundaries. The empirical rule says within the boundaries. I noticed it was 21 data values. Out of the total of 31, I converted that to a percent, and there you have it, 67.7. That one's kind of right on the money. So let's see what happens with the second standard deviation. The empirical rule does this 3 times. All right, so for here, we'll designate this as x bar plus twice the standard deviation. And I'll go over here. This is going to be x bar subtract twice the standard deviation. Now, the empirical rule, remember, says this is supposed to be about 95%. So from here to there, the empirical rule says we're supposed to catch 95% of the data values. So again, I know it's going to be something out of 31 here. It's just a matter of how many of them, fall in there. Well, what we need to know first is, what are those values? I think I might have made this a little too big here. So let's get those values first. So 83.6 subtract twice the standard deviation of 4.2. All right, so that value is 75.2. And if I do the same calculation with an addition sign in there, that value is 92. All right, so once again, we got to count how many of the data values fall within 75.2 and 92. Now, I'll be honest, it's easier actually if you, instead of counting the ones that lie in there, count the ones that don't lie in there, because I mean it's going to be close to 95%. Almost everybody's going to fall inside there, almost. So then I think we should just count how many people don't fall in there. It'll just be easier for us. So who doesn't fall in there? Well, this guy doesn't, right? 74 doesn't fall in there. And neither do these two, the 92 and the 94. Now, some people would say, what are you talking about? The 92 lands in there. 92 technically lands on the 92, right? So the empirical rule says within, means in between, not including that value. So we're going to, to go according to the definition, let's just leave the 92 alone for now. So as you can see, out of the 31 data values, 3 of them don't land within those 2 numbers. So that means 28 of them do land in there. So this is 28 out of the 31 data values land within there. All right, so again, the empirical rule says it should be about 95%. So let's see what we got here. 28 out of 31. 90.3%. Now, that is a little bit low. It's not terrible, but this distribution, if you remember, when we calculated the histogram for it back in, I believe it was in chapter 2, that was probably during week 2. When we, calculated the histogram, it wasn't a perfect bell. It was pretty good though. This percentage is a little low. It's not going to hurt us though, as you'll see. All right, let's do this one last time. So the empirical rule again does this procedure 3 times. So this value here will be x bar plus 3 standard deviations. X bar subtract 3 standard deviations. The empirical rule says you catch just about everybody in the population here. This is actually 99.7%. So you're catching just about everyone in the population here. This is for a perfectly bell-shaped distribution. All right, so again, how many of the 31 values are going to land in there? Well, in order to answer that question, we first have to calculate what the values are. All right, so 83.6 subtract 3 times the standard deviation. That value is 71. And then 83.6 plus 3 times the standard deviation. 96.2. All right, well, giving that a quick look, every single piece of data falls within those 2 numbers. So that's 31 out of 31, which is 100% of the data. The empirical, remember, says that it's supposed to be about 99.7%. So as you can see, if you think about it, how does, this number right here, how does that compare to the empirical percentage of 68%? They're extremely close, right? How does the 90.3 compare to the 95%? It's not extremely close, but it's very close. And then, of course, finally, how does this 100% compare to the 99.7%? I mean, it's pretty much right there. So the 3 percentages that we get for our data, these 3 percentages, they are in fact in line with what the empirical rule says. So therefore, remember, the empirical rule only works for bell-shaped data. So therefore, our conclusion here is that this data is bell-shaped, or approximately bell-shaped. One other important thing you can see from this is this last empirical percent of 100%. That means that all the data lied within 3 standard deviations. And remember, in this chapter, we defined an outlier as any piece of data that lies outside the 3rd standard deviation to the right or left. So these are where the outliers live. And since no data value falls smaller than 71 or greater than 96.2, there are no outliers, and this is indicated with this last percentage. So this is no outliers. All right, so this is a lengthy procedure, as you can see. Once you do a couple of these, though, you get pretty fast at it. Creating this picture obviously takes some time. On the first exam, I would say this is one of the harder things to do, if not the hardest thing, or I wouldn't say hard. This is not a difficult concept here. It just takes time. So this is one of the more lengthy things that you'll have to do on your first exam. All right, I hope this helps, and if you have any questions, feel free to shoot me an email. Thanks for watching.